we're going to spend some time reviewing some Algebra 1. We're going to review multiplying polynomials and factoring quadratics. I'll let you fill that in, whatever assignment number we're on. Changes from year to year. So multiplying polynomials and factoring quadratics. Find my ruler. All right, so we're going to do an essential question. How do you multiply polynomials? What is the special multiplying pattern for two binomials? Oops, I'm not going to put a question mark yet. And how does it help you factor some quadratics? So some quadratics will, and quadratics means x squared or some variable squared. But some quadratics, if you have some of these, and you're very familiar with this special multiplying pattern for two binomials, maybe you've heard this before, FOIL, then it'll be really easy if you get used to multiplying two binomials in a certain way using FOIL, then it'll be easier to go from a quadratic, a trinomial quadratic, back into the two binomials. So basically dividing it back into two binomials. All right, and I may be saying way too many things right now that you're like, what? I don't understand any of this vocabulary. So, not to worry. I'll break it up a little bit for you. All right, so let's review some multiplying and some vocabulary here. So I'm going to give you a, and I'm going to multiply that into the quantity a cubed plus 2a squared minus 5. So what I have right here is I have two things being multiplied. The first factor, right? This is if we're multiplying two things together, those are called factors. And I'm multiplying a times this a cubed plus 2a squared minus 5. So the two factors I have are a and the a cubed plus 2a squared minus 5. That's another factor because they're being multiplied. Now the first factor right here, we would call this a monomial. Mono meaning one, okay? So monomial. And then the second factor with the three terms, well, what's a prefix that we usually use for things with threes? It's a tri, right? So a trinomial. So this factor is a trinomial. All right, now how do I multiply a monomial by a trinomial? Notice again that prefix tri. I'm basically just going to distribute. You've been doing this for a very, very long time. You should be very familiar with this. So you're going to take the a and you're going to distribute it to the first term. Well, a times a cubed, when you multiply bases that are alike, you add the exponent. So this gives us a to the fourth. Okay, so multiplying 2a squared times a is going to give me 2a cubed. And then multiplying the a times the negative 5 gives me negative 5a. And once again, I'm left with a trinomial. This trinomial happens to be 1 power higher than the trinomial that I started with because I multiplied by a to the first power. Okay, so that's just regular distributing. Okay. Now, what if I did something like, ooh, how about 2 trinomials? This can get a little bit tricky. So, x cubed minus 3x squared plus 5. And then I'm going to multiply that to x squared minus 2x plus 1. So now I have 2 trinomials being multiplied. Well, when I do this, it's still distributive property, but it's like distributive property on steroids, okay? You're like triple distributing. So I'm going to take the x cubed, I'm going to multiply it to x squared. I'm going to go down here because I'm going to get a lot of terms out of this. So once again, like bases, so I add the exponents. So I get x to the 5th. Then x cubed times negative 2x gives me negative 2x to the 4th. And x cubed times positive 1 gives me positive x cubed. Okay, first term in the first trinomial is taken care of. I'm going to move now to the second term in the first trinomial. So now I'll distribute this. Maybe I'll go under here. So I get 3x squared, or I should say negative 3x squared, times x squared gives me negative 3x to the 4th. Negative 3x squared times negative 2x will give me a positive 6x cubed. And then negative 3x squared times positive 1 just gives me that negative 3x squared. And now I'm going to do one more term because I've got that last term in that first trinomial that also needs to be distributed. Kind of out of space here, but I'll just go up above here. So distributing that, I get positive 5x squared, negative 10x, and positive 5. Okay, so we're working up to some of those problems where this is why we want to be nice and neat with our work. We want to be able to write it all out, be able to follow our work, because if we can't, problems just keep getting more and more complex, and if you can't follow your own work, you're not going to be able to keep everything in your head, okay, especially as we go on in mathematics. Now it's time to combine like terms. So I'm going to look for other x to the 5th. I don't see any other x to the 5th, so I'm just going to leave x to the 5th here. Now I do see another x to the 4th, so I've got a negative 2x to the 4th and a negative 3x to the 4th, leaving me with a total of negative 5x to the 4th. So when you're adding or subtracting, okay, you're not going to be getting any higher exponent values, right? We're just combining like terms. So we're just combining the coefficients that are in front of those variables. All right, so I'm done with the x to the 4th. Now I'm going to move on to the x cubes. I seem to have an x cubed and a 6x cubed. So I'm going to have a total of 7x cubed. Okay, what else do I have here? I have a couple x squareds. I'll box those. So when I combine those, I get a positive 2x squared. Then a negative 10x and a positive 5. All right, so I think that's our final answer. So I'm going to go ahead and put a box around that. No more like terms, and I took care of every term. Notice I like touched every term in some way until I got to the very, very end. But the rest of these I either underlined, circled, boxed. I did something so I knew that they were like terms and that I had dealt with them. Now there's a very special case of multiplying polynomials. So whether it's a monomial, a trinomial, a binomial, if you have one term or more, we call these polynomials, okay? So when you're multiplying polynomials, there is a special case of multiplying polynomials. And that special case is when you take a binomial, which is 2 terms, and you multiply it by another binomial, right? So maybe I'll put parentheses around them. You got 2 terms times 2 terms. That's what binomial means, okay? Okay, so when we do this, something that we can use is FOIL. F-O-I-L. And what does FOIL actually mean? Well, let me go through this with you, and then we'll break down what FOIL is in case if you haven't heard it before. So an example of this would be 7x plus 2 times 5x minus 3. Now, FOIL is just distributing. Okay, it is distributing, and I'm going to prove that to you. So with this, you probably at some point learned double distributing. Great. So I take my first two terms, right? Those are the first two terms in each binomial, and I multiply them together. So here, I'm going to write down here FOIL, F-O-I-L. So you always start with the first two terms, just like double distributing. That gives you 35x squared. Okay. Now you do, when you double distribute, you now do your outers, right? The two outer terms in these two binomials. Well, guess what the O stands for? Oops. We don't want two O's there. It stands for outer. Oh, boy, I'm really not otter. I got this. It's sunny outside. I want to get outside. Outer. Okay, sorry. All right, so double distributing would also have me do that, right? It's negative 21x. Okay, now continue with distributing. I'm going to take that 2. I'm going to multiply it to the 5. Guess what these are? These are our inner terms. Okay, so I'm going to multiply those. I get positive 10x. And then, continuing with distributing, I do my last terms. And doing that, I get negative 6. So when I simplify it all out, I get 35x squared. My inners and outers are always like terms. Okay, these two right here are going to be like terms. And they will give you your middle term. So my middle term here is basically, because they're alike, I can combine them. I get negative 11x minus 6. Okay, so that is double distributing or FOIL. Now, you can actually use FOIL to make this make a little bit more sense to you when you have to work backwards. Because here's what's going to end up happening. I'm going to give you this, and you're going to need to work backwards to that. Okay, so I'm going to give you the product, and you're going to need to divide it up into two binomials. And this is key. This never leaves you. As long as you are working in mathematics, you will be factoring for the rest of the time that you work in mathematics. And those of you that are staying with me through your entire high school career will be doing lots and lots and lots of this. We'll even do this in calculus. Okay? And then those of you that are going on to college, you're going to need a math class, at least one. Some of you that are going to be doctors and engineers, you're going to need many more than just one. But every single one of you that goes to college and you're going to get a bachelor's degree or a master's degree, you're going to have at least one math class. And guess what? They're going to make you do this. One college level math class, I should say. Okay, so factoring doesn't go away as long as you are practicing mathematics. So it becomes a very, 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 very critical skill. Let's see. So I'm going to now do this exact same problem, but I'm going to do it a little bit differently, showing you how to quickly work with FOIL. Okay? So, same exact problem. Let's see. Maybe I'll just do it. Where's the best place? How about I just do it right here? So that way we can still see this and have it over here to the side. So I'm going to take that 7x plus 2, that 5x minus 3. Okay. So, first thing I do is my first terms. That gives me the 35x squared. You're like, yeah. Oops, actually. Don't write it right there. Go down. Skip like 2 lines. So I do my first terms, which we've already done. You get 35x squared. Now, super quickly, you do your inners, which give you 10x. So practice this. Inners give us 10x. Outers give us negative 21x. And when I combine those, I get negative 11x. I haven't actually skipped any steps so far, right? I have the exact same stuff here that I had right here. It's just written in a little different format. Okay, and then my last two terms give me that negative 6. Voila, I'm done. I got the exact same answer. basically the exact same way. But here's what's going to happen. See, we're going to have to take 35 and 6. We're going to have to break it up. So we're going to, when we go back and we factor, we're going to take 35. We're going to say, oh, factors of 35 are 7 and 5. And we're going to put those in the two first places. Then we're going to take factors of 6. And we're going to take those two factors, like 2 and 3, and we're going to put them in the last two places. And then we're going to sit there and we're going to mess around with our inners and our outers to make sure that our middle term is exactly the middle term that we want. Okay, so that's how we're going to go from this trinomial back to the two binomials. So if you can get really good at doing FOIL, you'll understand where these numbers come from, how they make up that number, and how they're related to these two numbers. So I think that FOIL is a great practice. It'll set you up really, really well for factoring. All right, let's do one more here. I'm going to show you another model of how we could possibly multiply these things together. So another example, we'll call this one example 1 because I'll give you some directions here. So the directions are to FOIL, and you're going to do 4n plus 1, and then 2n plus 6. Okay, and I'm going to show you two ways to do this as well. So foiling is going to be probably the most helpful with factoring, but some people also like the box model or the area model. Okay, so I'll talk about that in a minute. Let's go ahead and practice our foiling though. So we start with first. So you do the first ones. I'm going to skip 2 lines. I get 8n squared. I do the outers. The outers give me 24n. Oh, I don't like how I wrote that. I needed to skip a space there because my inners need to go above it. So we'll do our outers, which will give us 24n, right? So O. Then we'll do our inners, which will give us 2n. Then we'll combine those together to get our middle term, which is 26n, and it's a positive 26n. And then we'll do our last to get positive 6. And voila, we are done. Pretty simple. Let's also look at that using an area model or a box method. So another way that you can do this, because multiplication, think of this as like multiplying base times height. So if I were to create a box, and I tell you, okay, this side right here will be like 4n plus 1, and this side right here will be like 2n plus 6. I can then multiply and get the total area of this. So basically when you're multiplying these two binomials, it's like taking these dimensions, the base and the height, and getting an area. So I can take my first two terms and I can multiply them. That gives me that 8n squared. Okay, does that make sense? Because this is the, let's call that the base of this square here, and the height, they'll probably be rectangles because they're not the same. But base and height gives me the area of that square right there. Okay. So now if I take my outers was the 4n and the 6, right? The 4n and the 6. If I do my outers next, 4n and 6 gives me the 24n. If I have my inners then, okay, my inners were the 1 and the 2n. 1 times 2n, 1 being the base here, 2n being the height. I get a total of 2n. And then my last box here is going to be my last two terms. 1 times 6 gives me 6. Notice that these are like terms because these come from the outers and the inners. And that gives me a total of 26n. So you have a total of 8n squared plus 26n plus 6. And that matches exactly, right? Oops, sorry. So that's just another way that we can look at this. All right, I'm going to let you guys practice that today. So you have some worksheets. Oh, let's see where they go. Here we go, multiplying polynomials. All right, so this worksheet right here, multiplying polynomials, that's the one that I want you to do today. So you're going to do 6v, this is a monomial times a binomial, so it's just regular distributing. However, every time that you see two binomials being multiplied together, please, please, please use FOIL. And you can also use the box method, but definitely practice using FOIL. Because when we go back and we have to divide out the trinomials back into these, it's going to make it a lot easier. So then, let's see what else you got here. You've also got like a binomial times a trinomial. That's just straight up distributing. So the only special case is when you have a binomial times a binomial, and that's when you FOIL. Okay, otherwise there's no first, outer, inner, last, right? Because now you've still got first, you've still got outer, but what's your actual like inners? Is it 2 times 6a squared? Is it 2 times a? There's too many terms here to determine. You've also got a trinomial times a trinomial. Okay, so we'll make this day 1. So I think actually I'm going to go into our notes. I'm going to call this day 1. And so day 1's assignment is the multiplying polynomials. And then next time I see you, we will do the factoring. So the rest of this, the factoring quadratics, the rest of this assignment.